Assalamualaikum warahmatullahi wabarakatuh, and have a good day to our beloved lecturer, which is Dr. Wan Faida binti Wan Muhammad Azmi. So today we are going to present about basement construction. Before we start our presentation, I would like to introduce my team members and also myself. So my name is Nurhanis Irani binti Haris, and my other team members are Hanim Karamila, Nur Suryani, Nurul Fazliani, Siti Rabita, and Nur Hazwani. As we all know, Malaysia has experienced significant economic growth since the 1970s, and it is leading to the construction of high-rise buildings, especially in metropolitan areas like Kuala Lumpur Convention Centre, KLCC. However, due to limited land availability in urban areas, Malaysia's construction sector relies heavily on basement excavations to create additional usable space for utilities, parking, storage, and even leisure areas. Other than that, basement construction in Malaysia requires careful planning, skilled labor, and appropriate materials to ensure structural integrity and performance. Basically, basement projects are often designed using fast-track methods to reduce construction time. As land becomes scarcer, the demand for underground space has led to the creation of multiple layers of basement, helping meet the need for commercial centers and office buildings in densely populated areas. And for your information, basement provide valuable usable space without increasing a building's footprint, and they offer flexibility for different purposes like office or storage. Additionally, they can enhance the property's value and provide structural support by acting as foundations for the building. First excavation and construction technique that we have is open cut excavation methods. The open cut method involves excavating a trench or pit for basement construction with two main variations, which are the open cut slope method and the open cut cantilever method. The slope method is cheaper and does not require retaining walls, while the cantilever method is more expensive but allows for deeper excavations, making it suitable for projects requiring significant underground space. So for the excavation process for this technique is starting with site preparation, which includes clearing debris and marking construction boundaries. Excavation follows, where a trench is excavated to the required depth using heavy machinery. Afterward, a foundation is laid and the basement walls, floor, and essential systems like plumbing and HVAC are built. Once the basement is complete, backfilling is done by layering and compacting soil around the structure to ensure stability and prevent future settling. The final step is site cleanup, which may include landscaping and fixing any damage to the surrounding area to make the site functional and safe. So, the second excavation method that we have is cut and cover method. This technique involves excavating a road or tunnel in sections, building the tunnel, and then refilling the trench. It is important to install drainage and waterproofing before backfilling, and secondary roads are repaired afterward. Landscaping is done to restore the environment, including planting trees or grass. Other than that, this method involves grading the area with minimal trenching and constructing a concrete vault beneath the surface to protect the excavation. Once the vault is in place, the tunnel is built. This technique is especially useful for urban subways, ensuring safety and minimizing disruptions. The open cut process starts with clearing the site, marking excavation boundaries, and preparing a clean environment. So after the tunnel construction, backfilling is done to stabilize the structure and restore the site with compacted soil to prevent water seepage. The site is then cleared for landscaping or further construction. The last one is top-down construction. The top-down construction method allows for simultaneous work on both the underground and above ground levels. Excavation and building construction occur at the same time, which reduce the overall project timeline significantly compared to traditional method. The method involves building perimeter walls and foundations to support the structure while excavation continues. Temporary superstructures are used to support the upper levels during basement development, ensuring stability and safety throughout the process. Once the underground levels are complete, work on the above ground structure begins. The completed underground areas serve as a solid framework for the rest of the building, ensuring a seamless transition and improving the overall efficiency of the construction project. Next, I will talk about waterproofing and drainage system. Waterproofing is essential for preventing moisture in basements, which are especially for underground location. This drainage system help prevent water accumulation and mold growth, also ensuring basements remain dry and livable. We have two types of waterproofing, which are interior and exterior. Interior waterproofing addresses water that has already entered the basement using drainage systems like French drains and sump pumps, along with waterproof sealants to keep the interior dry and prevent water accumulation. For exterior waterproofing, it involves excavating around the foundation to apply waterproof membranes and coatings, along with drainage systems to prevent water from reaching the foundation, offering a long-term solution to moisture issues despite being more labor-intensive and costly. Impermeable mortars and bituminous coatings are key waterproofing materials. Mortars create strong barriers against water and pressure, while bituminous coatings form flexible hydrophobic membranes that repel water. Lastly, I think combining both methods, which are exterior and interior waterproofing, will ensure comprehensive water protection. So for the last part in literature review, which is electrical and plumbing requirement. Proper electrical systems in basement ensure safe and reliable power for lighting, heating, and appliances. Following NEC guidelines to prevent hazards like water damage, using GFCI for protection. Effective lighting design, including energy efficient fixtures like LED, is essential in basements with limited natural light, ensuring comfort and functionality in work and living areas. In addition, plumbing systems in basements are essential for water supply and drainage. So it will ensure proper functionality and preventing issues like leaks and flooding that could damage the structure. Plumbing systems in basements also are essential for water supply and drainage, ensuring proper function in areas like bathrooms, kitchens, and laundry rooms, and preventing leaks or flooding. Some pumps play a key role in maintaining a dry basement by removing excess water due to heavy rainfall or groundwater seepage, protecting the structure from water damage. So the properly installed electrical and plumbing systems enhance basement safety, comfort, and efficiency, while preventing hazards such as electrical shock or flooding, ensuring a long-term functionality and safety.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Rakta binti Ramli. For the case study 1 is Ilham Baru Tower. The project background, the Ilham Baru Tower is known as IB Tower, owned by the IB Towers neighborhood. It is one of the skyscraper in Malaysia with the height from the ground around 2,075 meter. It is one of the mixed-use development in Malaysia which combine the residential and office building. The building is awarded with the BBCA Green Mark Gold Plus certification in 2013 because of the implementation of sustainable. The total cost for this project is around RM2 to 5 billion. This project was proposed in 2010 and completed in 2015. The location of the building is at Lorong Binjai, Kuala Lumpur, Malaysia, with the other skyscraper building like KLCC and TRX. Next, for the parties involved for this project, the client is Ilham Baru Tower, or known as IB Tower Sdn Bhd. For the project manager is Plenitude Builder Sdn Bhd. The architect for this project is SA Architect Sdn Bhd. For the design architect is Foster and Partners. The quantity surveyor for this project was Arcadis Malaysia Sdn Bhd and Davis London and SAS Sdn Bhd. For the civil and structural engineer is T.Y. Lin International Sdn Bhd, and for the mechanical engineering is Juruterra Perunding Waldun Sdn Bhd. The contractor has three, which superstructure, substructure, and basement contractor. For the superstructure is Daewoo Engineering and Construction Co. Ltd. For the substructure is Jopanka Sdn Bhd, and for the basement contractor is Tian Makmur Sdn Bhd. Next, for the basement excavation for case study 1, the excavation and construction technique used for this project is semi-top-down construction method, which is suitable for urban area where the space is limited. For the waterproofing used for the Ilham Baru Tower is waterproofing with holes, external waterproofing membrane and crystalline waterproofing membrane, which the function is to prevent the water ingress the basement. For the drainage system, the perimeter drain and some pumps are used to redirect water away from the basement. Next, for the ventilation and air quality consideration, it's important to replace the indoor air with outside air to decrease the humidity and bad smells, especially in the basement. So the suitable ventilation system for Ilham Baru Tower is by using the mechanical ventilation. Next, for the electrical and plumbing requirement, need a careful plan to construct the basement electrical because to avoid the electrical equipment from the water moisture.
My name is Nurazani binti Abdul Halim. I will present about the problem encountered and solution of the construction for Ilham Tower. Okay, Ilham Tower is a marvel of a modern architecture in Kuala Lumpur and is standing tall at 274 meters. However, the construction faced a significant problem due to its urban location and unique requirement. The Ilham Tower faced two primarily problems during its construction, which is congested area and limited space. That the project was located in the bustling heart of Kuala Lumpur, and it only have a single access route, which is heavily trafficked due to the peak hour, and it's near the KLCC, and KLCC is a tourist attraction, so that we make the transportation of material and the removal of excavated debris difficult. And also, the site have a limited space, so that means there are no room for the material storage of or disposal. The second problem is subsoil condition and surrounding buildings. The site was part of the Canny Hills formation, which is characterized by the sandy silt layer and this poses risk of ground settlement and structural instability. To ensure the precise, engineer will avoid any adverse impact because it's nearby high-rise buildings and it will put more pressure to the soil. To overcome this problem, the project team implemented innovative solution, which is a transportation management where the material transport was rescheduled to off-peak hour and mainly at night to reduce traffic congestion. And also the multiple loading trucks were stationed to handle excavation debris promptly. The second one is enhanced basement design. The diaphragm wall was meticulously designed to withstand the lateral soil pressure, and the temporary crown, anchor, and a basement ring slab were introduced for additional structural support. To avoid any addition issues, the instrumentation and machinery was added. Advanced monitoring system were installed to track ground movement and ensure the stability during the excavation. Drawing from the problem and solution, here are the key recommendations for the future project, which is we have to do this site-specific engineering, which you have to conduct comprehensive subsoil investigation and tailor the design to a local condition. and use advanced construction method like semi-top-down excavation for urban site because for the example, the Ilham Tower have a very big construction and a very big building. The definition of the semi-top-down excavation is a hybrid construction method that combines elements of both bottom-up excavation and top-down excavation, and it is specially designed for urban environments and challenging sites where space and structural stability are constrained. This construction, we start with the bottom excavation to a specific level, and this will continue with the top-down constructions technique for the remaining substructure. During the excavation process, intermediate floor slabs are cast. These slabs serve as a temporary support, help stabilize the structure as a deeper level are excavated. And this method will also enhance the stability where the breaker slab act as a horizontal struts, providing additional lateral support to the excavation wall and reducing the ground movement. Another method I will recommend is transportation planning, safety and monitoring, and also um, the engaging with a local communities and stakeholder early. That's all. Thank you.
Assalamualaikum. My name is Nur Suryani. Our second case study is MRT Station Bukit Bintang. The Bukit Bintang MRT Station is part of Malaysia's Klang Valley Mass Rapid Transit (KVMRT) project and serves an important link on the Kajang Line. It is strategically located in Kuala Lumpur Wizi Commercial District. This underground station is designed to reduce traffic jam and enhance connectivity in one of the city's most vibrant areas. There are a few parties involved in the construction of MRT Station Bukit Bintang. The Mass Rapid Transit Corporation Sdn Bhd as project developer. They are involved in overall management of the project, starting from identification of the problem, formulation of a plan, execution and monitoring. Second, MMC Gamuda KVMRT Sdn Bhd as main construction company, principal contractor for the MRT subway segment and a vital station at Bukit Bintang. Then Ministry of Transport Malaysia and the Land Public Transport Agencies as government agencies. Daily regulatory roles overseeing transportation policies, regulation and the supervision of land public transport and activities related to the MRT project. Next, Kuala Lumpur City Hall as local authorities to ensure that the project conforms to local zoning, urban planning and municipal law, thus contributing to the seamless integration of the project into the city's infrastructure. Lastly, Rapid Rail Sdn Bhd as operation and maintenance. They will take charge of its operation and maintenance, ensuring smooth and safe operation of the commuters. Next, excavation and construction technique used in construction of MRT Station Bukit Bintang. There are 6 stages for the construction. First stages is excavating done using mechanical diggers. Second, most concern regarding the location support is located is precisely before execute underpinning or piling work. Third, underpinning the piling work using auger drape piling. Stage 4, retaining wall is important in this stage to retain support to the soil. Stage 5, to lay and apply the waterproofing to the basement excavation. And lastly, concrete to be put to basement surface, evenly obtain finish work. Next, waterproofing and drainage system. For waterproofing system, MRT Station Bukit Bintang located in Kuala Lumpur, Basling Commercial District employs modern method of waterproofing to guard the underground structure of the facility. Due to high groundwater, a lack of experience by other bidders in carrying out waterproofing and the station being placed near big water sources, waterproofing issues at the station had to be addressed to avoid water leakage and compromising the durability of the construction. One of the most important components of the waterproofing system is bentonite waterproofing membranes. Bentonite is one type of clay that upon mixing with soil tends to show very good results by expanding when in contact with the water to form a compact and waterproof layer, thus making it ideal to be used in problems related to water pressure and water motion. The sheet or panel of bentonite membrane used in the construction of MRT station Bukit Bintang, which is put on the outside of the wall and floor surfaces of the underground station. The installation process involves fixing or bonding the bentonite panels by a mechanical means to the subsurface. When the constructed surface is exposed to water, the bentonite expands and fills the pores, thus placing a continuous wrap around the fastener. Other major benefits of bentonite include self-healing. Where there is minute cracking on the concrete structure surface, the bentonite will swell up to seal these cracks and preserve the barrier against water seepage. For drainage system, due to concern of high groundwater table level that are typical of the Bukit Bintang area, MRT has an efficient basement drainage system in its Bukit Bintang station. The drainage plan largely comprises a perimeter drain system as well as basement slab drain network. External adapted in the installation of the perimeter drainage system include the use of perforated drainage pipe along basement walls. It buried in trenches containing gravel that help drain water, relieving the pressure against the wall of the basement, thereby preventing percolation of water through concrete walls. An underslab drainage system of perforated pipe is in a bed of gravel under the basement floor that collect water leaks and flow it toward a common sump pit. Installed in the pit, sump pumps such collection of water accumulation must automatically be discharged into the safe area in order for a dry basement to result. Due to this intense draining method, MRT Bukit Bintang station eliminate all sorts of potentially for the entrance of water to basement to prevent structural deterioration by preserving them for more years service life.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hanim Karmila. I will be introducing the MRT Bukit Bintang station today, which is a major accomplishment in the growth of Kuala Lumpur urban infrastructure, part of the Sungai Buloh Kajang MRT line. This project is in the center of the city commercial and entertainment district and aim to improve the city transit system and lessen traffic. Let's look at the challenges, solutions, and development in technology that led to this important achievement. So for the key challenges, there were several difficulties with the project. Under Jalan Bukit Bintang, in a highly populated location and circled by tall building and vital infrastructure, the station first needed to be excavated 28 meters deep. It was crucial to make sure that organization, cars, and pedestrians could all access the area safely. Additionally, maintaining structural integrity and preventing disturbance were crucial due to station close proximity to the KL monorail and large utility networks. The first challenges is construction technique and groundwater management. The top-down construction method was used to address this issue. This creative method minimized surface level disruption while allowing simultaneous excavation and structural work. Soil stability and the safety of neighboring structures were guaranteed by reinforced diaphragm walls to control the high groundwater table and guarantee safe excavation and structural integrity. Extensive dewatering and waterproofing measures were put in place. The second challenges is safety measures and accessibility. Accessibility and safety came first. To safeguard the public and employee, the site was reinforced with strong barriers and visible signage. To guarantee preparedness for possible incident, emergency action plans were established with local agencies. To reduce business disruption, safe pedestrian paths and access routes were installed. Additionally, part of Jalan Bukit Bintang remained accessible during the project because of the arranged building approach. And the last challenges is managing existing infrastructure. Temporary support structure were put in place to safeguard its operation because of its proximity to the KL monorail. To prevent interruption in service, advanced methods such as ground penetrating radar were used for utility mapping and relocation. Effective communication with utility providers and stakeholders ensure smooth coordination and speedy problem resolution. And next, for the solution to all the challenges I said before, which is the first one is monitoring system. Real-time monitoring system were built to track vibration, earth movement, and building settlement throughout the project. This system enabled the team to identify risks early and carry out quick corrective actions, ensuring the stability of the surrounding buildings and the safety of the public. Another solution is public engagement and stakeholder collaboration. Collaboration among stakeholders was important for the project's success. Disruption were reduced through regular engagement with the public, local government organization, and business. Program for public awareness inform the public about possible effects and the steps being taken to prevent them, or inviting collaboration and support. For the recommendation, based on this project experience, I recommend adopting modern construction technique like the top-down method for urban projects. Space excavation, reinforced diaphragm walls, and real-time monitoring are crucial for ensuring safety and stability. Effective stakeholder collaboration and public engagement should also be prioritized. Lastly, leveraging advanced technologies like LOT-based monitoring and digital twin models can further enhance project efficiency and safety. To sum up, the MRT Bukit Bintang station serves as an example of how to create urban infrastructure. It demonstrates how finding outcome can be attained by finding a balance between technical innovation, safety, and community effect. This project has raised the bar for infrastructure development in Malaysia and globally, demonstrating the value of teamwork and engineering ability in solving difficult urban problems. Thank you.
Assalamualaikum. My name is Nurul Fazlani. I will explain about compare and contrast between two case studies. First is similarities between Ilham Baru Tower and MRT Bukit Bintang. The first similarities between Ilham Baru Tower and MRT Bukit Bintang is high initial construction costs. Both projects incur significant expenses due to their large-scale commercial nature and complexity. It's also requiring a skilled professional throughout various construction stages. Second is limited on-site space. Both construction face challenges in managing limited space for storing equipment and materials, leading to increased transportation costs and logistical difficulties. The third is geographical proximity. Located in Kuala Lumpur, both buildings are situated in densely populated area with heavy traffic, complicating the delivery of material and access to the construction site. Next is transportation challenges. The congested urban environment of Kuala Lumpur creates difficulties for transporting material on-site and off-site, impacting overall project efficiency. And the last one is risk of material thief or damage. Due to limited secure storage options, both projects face risks related to material handling, including potential thief or damage, which could lead to increased costs through double handling. Next, we go to the differences between two case study. For the Ilham Baru Tower, method that have been used is semi-top-down excavation. Reason for choice is limited working and storage space on site. The advantages, Ilham Baru Tower is cost-effective for creating permanent structure, avoiding expensive foundation like rock-socketed diaphragm walls, and minimize lateral movement of retaining walls, relying on the earth bank condition for stability. However, MRT Bukit Bintang, the method used is top-down excavation. The site surrounded by 16 buildings, complicating traditional construction methods. The advantages is save time by allowing upper level to be constructed while the basement is being excavated. Ilham Baru Tower is reduce disruption to the urban environment, ensure strong foundation and structural stability, and align with project specification, budget constraint, and site conditions. For the MRT Bukit Bintang, first is efficient for urban environments, allowing for effective management of space and resources. And the last one, each technique offer unique advantages regarding stability, cost effectiveness, and operational efficiency. The efficiency for Ilham Baru Tower, the method used is semi-top-down construction. For the building speed, it enables faster progress by constructing basement level before above ground structure, reducing extensive excavation. However, for MRT Bukit Bintang, the method used is utilize tunnel boring machines, which is known as TBM. Building speed for TBM, allowing for timely project completion with minimal surface disruptions. Okay, next, efficiency is cost effectiveness. For the Ilham Baru Tower, it's lower expenses related to excavation, foundation installation, and waterproofing. It's also minimized need for complex shoring and dewatering systems. For the MRT cost effectiveness, TBMs are cost effective due to reduced pollution and disturbances, while immersed tube technology uses prefabricated section to enhance efficiency. And the last efficiency is environmental impact. For the Ilham Baru Tower, technique like diaphragm wall and slurry barrier reduce soil disturbances and positively contribute to surrounding ecology. However, for the MRT Bukit Bintang, environmental impact sustainable practice reduce surface disruption and pollution compared to traditional methods. Cost analysis, first is excavation depth. For the Ilham Baru Tower, use shallower excavation. It's leading to lower overall cost. However, for MRT Bukit Bintang, greater depth required for underground station. It's increasing excavation costs and necessitating advanced shoring techniques. The second cost analysis is waterproofing needs. Ilham Baru Tower use basic waterproofing methods suffice, resulting in lower expenses. However, for MRT, it's require modern waterproofing technique due to depth and proximity to groundwater. It's also involving high performance membranes and complex drainage system. The last cost analysis is MEP systems. Ilham Baru Tower relatively simple system designed for utility services and parking areas, minimizing complexity and cost. However, for the MRT, it's more complex system needed for transit operation, including extensive electrical infrastructure, fire safety measure, and ventilation systems. It's contributing to increased costs. Summary of cost differences. The MRT Bukit Bintang station incurs significantly higher costs compared to the Ilham Baru Tower due to its greater excavation depth, complex foundation requirements, advanced waterproofing needs, and sophisticated MEP system tailored for transit operation. This factor highlight the distinct financial implication of infrastructure project designed for public transportation versus commercial development.
So, for the conclusion, basements are essential for a building's foundation, which is providing extra living space and helping control temperature, despite being often overlooked. Common basement issues include lack of natural light, foundation problems, and water seepage, which can be addressed through solutions like adding windows, waterproofing, and proper drainage. So building a basement is usually cheaper during initial construction compared to adding one later, and the cost depends on factors like size, complexity, and location. The design of the basement should match its intended use, and basic designs may work for storage, but for living spaces, proper ventilation, exits, and moisture control are essential. A well-planned basement adds valuable space at a reasonable cost, while poor design can lead to ongoing issues and expensive repairs.